All right, well, hello physical science students, and welcome to this video lecture on states of matter. As was mentioned previously in this unit, there are now 5 states of matter. However, we need to understand some basic characteristics of our big 3 states of matter, which are solids, liquids, and gases. So, to begin, for solids, first thing we know about solids is that those particles are tightly packed together. Okay, particles are tightly packed. Now, that has some implications for us in terms of the rest of these characteristics. Okay, because these particles are tightly packed, solids have a fixed shape, and they also have a fixed volume. So what I mean by fixed is that it's not changing. Okay, imagine that the table that you're sitting at. Well, those particles are very tightly packed together, so that table has a very fixed shape. I mean, yes, we could lop off a corner of it. We could drill a hole in it. That would change the shape. But without doing anything to that solid, it has a fixed shape. And along with that, then, it has a fixed volume. Now, for liquids, we know that the particles are a little freer. Okay, particles are freer. Is freer a word? I don't know if it is or not. Particles are freer than in solids. I'm going to denote that they can flow. And because of that, liquids have a non-fixed shape. However, our particles in liquids, they are free to flow. However, they're not free enough for us to not have a fixed volume. So we do still have a fixed volume when we are working with liquids. Now, last but not least, we have gases. And gases is where those particles start to get real crazy. So particles, I'm just going to say, go wherever they please. Okay, so gas particles are going all over the place all the time. There's a lot of energy there. They can do whatever they want. Now, because of that, gases have a non-fixed shape. So when I say a non-fixed shape, we can also think of that as take shape of container. Same thing down here. Take shape of container. I mean, so imagine that you have some water and you pour it into a glass. Well, that water is going to take the shape of the glass. So liquids and gases both take the shape of their container. Now, again, with gases, because those particles can do whatever they want, they go wherever they please, gases have a non-fixed volume. Okay, so these are the big characteristics with solids, liquids, and gases. And through that PhET simulation, you should have seen what the particles look like in solids, liquids, and gases. Okay? Now, our next phase or state of matter is plasma. And plasma is pretty unique in that it is 99% of the matter in our universe. Now, what is plasma? And this is where states of matter get a little more complex. The way I'm going to describe plasma is that it is an ionized gas. Now, what does that mean, Mr. Welch? Well, plasma is created by adding enough energy to a gas so that some of the electrons actually leave those gas atoms. So a plasma is composed of positive ions and electrons, which is a very unique case. That doesn't happen in the states of matter that we're used to dealing with, solids, liquids, and gases, okay? Typically, we just have the atoms there. So you don't necessarily have to know what all this stuff means. However, I just want you to understand that plasma is it's like almost gas on steroids, okay? That gas has so much energy that electrons actually leave those gas atoms, and you're left with positive gas ions and electrons just floating around. Now, an example of plasma that we should all be familiar with and that I want you to really remember is lightning. Okay, so that bolt of lightning that you see is actually plasma. So there is a real world example of plasma for you, one that we can actually see on Earth. The other 99%, okay, is actually seen out in outer space, in stars, in our own sun. But lightning is an example of plasma that we can see here on Earth. Now, our last state of matter, the Bose-Einstein Condensate. Now, this matter state of matter is even weirder than plasma. First big note here is that the Bose-Einstein Condensate has never been found in the natural world. It's only been created in the lab. So it's only been created in a lab. Now, what the Bose-Einstein Condensate is it is a piece of matter that is created by getting to temperatures very, very close to absolute zero. Now, what absolute zero is a temperature which is 0 Kelvin, and Kelvin is another temperature scale that we use in science. But what absolute zero is it's the temperature where particles no longer move. And to put this in a context that we understand, absolute zero is negative 459 degrees Fahrenheit. So very, 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 very cold. Now, when we can get down to temperatures like this, okay, particles slow down and completely stop moving. And what happens once those particles slow down and completely stop moving, we cannot differentiate one particle from another. So what the Bose-Einstein condensate is just kind of this big blob of matter. Okay, it's, again, once these particles slow down and stop moving, we cannot tell one particle from the next. They all kind of just mingle together. And we can almost think about it like it's a solid on steroids, I guess you could say. So you don't necessarily have to remember all of this stuff. I just want you to understand that the Bose-Einstein condensate, it's not naturally occurring because we can't really in nature ever get to absolute zero. But the big key here is that those particles slow down and completely stop moving, and we kind of just have this big blob of matter left over. Okay, so to summarize this video lecture, yes, knowing what plasma and Bose-Einstein condensate is, that's great. However, I think the keys to this video lecture are understanding those characteristics for solids, liquids, and gases. So take care, physical science students.